let's proceed to our next lesson, which is actually entitled the chemical bonds. So in an element, we have so-called a sharing and giving of charges, and that is actually be done in the name or in the process of chemical bond. So chemical bond is a force of attraction between atoms or ions that enables the formation of chemical compounds. So let's take a look with the key terms. Ions. Ions also carries a different charges. We have positive and negative charges. Okay, continuing our discussion, how chemical bond form. It's said that the chemical bond are formed either by the transferring of electrons, that I've said, giving of electrons, or sharing an electrons to one another. So by giving it and sharing it, giving or actually accepting it, the chemical bond can be formed. Okay. So it's actually said this, or it's actually mentioned a valence electrons. Of course, in a shell, or you can give and share an electrons, or you can share and accept an electrons in a certain process, which is called a valence electron. So let's define more what is valence electrons. So valence electrons is an outer shell electrons that is associated with an atom and that can participate in the formation of a chemical bond. Of course, that is actually, I said a while ago, that the valence electrons is the process by which you can share and you can accept the electrons. Continuing, that this is actually the representation or the illustration of a valence electrons. As I've said, valence electrons is the outer shell. So that this is the valence electron of a certain element. And this center is, of course, the nucleus of it. Nucleus is the center of an element, the center of the negative and positive, and both negative positive charges of a certain element. So always remember that one. Continuing, in a general tendency of an atom, what happens when an atom that tend to give an electron? The metals, of course, are brought near atoms that tend to gain electrons, which is the non-metals, of course. Let's take a look with the representation or the illustration of the periodic table. The color blue itself is represents as the metal. This is the metal. The color green itself is represents as the metalloid. This element is actually includes in a metalloid, and the yellow color is represent as a non-metal. So this is non-metal. This elements is included in non-metal. So that is the representation of the metalloids and non-metal of the periodic table. Always remember that this blue, this one is includes in metal, and the green one is included in metalloid, and the yellow one is included in non-metal. So just to inform you guys that all of the periodic table has not the same of color. So please familiarize those elements that is in the metal, and those element that is in the metalloid, and those element that is in non-metalloid. Excuse me. Okay, continuing, let's define, of course, metal and non-metal ions. Okay, metal is said that have low ionization energy and readily lose electrons. Yes, of course, because metals is said as a positively charged element. Okay, when metal loses an electron, there is an imbalance of charges. Charged particles are called ions. When there is the charges of a certain element is called an ion. Okay, making it a positively charged particle. Always remember that one. When a metal loses electron, there is an imbalance of the charges, and that imbalance charges is called as an ions. Okay, always remember that one. Next slide. It said that a positively charged particle or the positive ion is called cations. Okay, as I've said, the types of ions we have, the positively charged is called a cations. Let's take a look with the illustration. Okay, as we all know that sodium has 11 protons and electrons has 11, sodium has 11 electrons also. That will be said that the sodium is actually has a 1 positive ion. Okay, always remember. I will be explaining it deeper in the next slide. So, always remember that if your elements carries a positively charged, it is called as a cations. Okay, next, non-metal. If metal has a low ionization in an energy because it has a positively charged, non-metals have a high ionization energy and readily take in electrons because non-metals is actually those elements that is actually carries an electrons charges or the negatively charges. So when a non-metal takes in an electron, there is an imbalance of charges. So that imbalance charges, as I've said, is called as ions, making it a negatively charged particle. So let's take a look with this. Always remember that if a negative charged particles or a negative ion is so called as an anion. If a positively charged particles or the positively ions is called as a cations. A negatively charged or a negative ion is called as an ion. Okay, always remember that one. So as you can see in the illustration in this one, chlorine atom or chlorine element has a 17 positive 17 protons and 17 electrons. So it has a balance of positive and negatively charged. So in the chlorine negative ion, we have the positive proton and 18 electrons. Of course, if this 17 electrons negative charge will share to another atom which is carries a 17 proton, it would be now a negative, or it will be now adding to 18 negative electrons. So always remember that one. Next slide would be the octet rule and some expectation in dealing the process of sharing and accepting an electron. Okay, most elements follow the octet rule in chemical bonding, which means that an element should have contact to 8 valence electron in a bond or exactly fill up its valence shell. Have 8 electrons total ensures the atom is stable. Always remember that in a valence electrons, we have 8 electrons. 8 valence electrons. So in an outer shell, dapat yung electrons niya ay may 8. That would be the explanation while an element has a stable electrons. If an element has in 8 valence electron, pag meron siyang 8, ibig sabihin, nandun na siya sa stable electron. Meron siyang stable electron. But if not, we will be undergoing in some types of chemical bonding, which is we will be discussing that in our next slide. Okay. Aside from that, some elements that are exception to the octet rule include aluminum, phosphorus, sulfur, and xenon. Always remember that in an octet rule that there is also an exemption, and those exemption is this element. This element we have aluminum, phosphorus, sulfur, and xenon. These elements are actually exempted in the octet rule. Okay, next slide. So this is actually the representation of a valence electron in an octet rule. Okay. Of course, in an outer shell or the outermost electron, the outermost electron can hold 8 electrons. The first electron shell can hold 2 electrons. Always remember. So, carbon would like to gain 4 electrons. Nitrogen would like to gain 3 electrons. And oxygen would like to gain 2 electrons. So, in the the valence electrons, we have the atomic number of carbon, we have 6, the atomic number of nitrogen, we have 7, and the atomic number of oxygen, we have 8. So, always remember the outermost electron shell, or itong first layer or the last layer, the last layer of the valence electrons can hold 8 electrons, and the first electron shell can always be hold 2 electrons. So, hindi yan maglalapas ng 3 because in the first shell, dalawa lang po talaga ang electrons. Okay, next slide. Let's go now on defining the types of chemical bonds. So, what are those types? That is actually when you share an element, anong tawag dyan? When you accept an element, when you accept an electron, sorry with the word. When you accept an electron, anong tawag dyan? Okay. It's said that the chemists refer to the force that hold together two atoms in a molecule as a chemical bond. A chemical bond are either by transferring the electrons from one atom to another or by sharing of electrons. So, a chemical bond is actually by giving it or sharing it or accepting it or gaining it. So, always remember that one. So, these are the types of chemical bonds. We have ionic bond, we have hydrogen bond, we have covalent bond, and we have metallic bond. So, let's dig deeper in the next slide. Okay, let's start with the ionic bond. This bond is actually called as a giving up an electron. As a result of electron transfer, the atom which is give up an electron becomes a positive ion, while the atom which accept the electrons becomes a negative ion. So that is ionic bond, giving and accepting electrons. Once an element give an electrons, it will become a positive ion. Once an element or an atom accept an electron, it become a negative ion. Always remember that one. Next slide. So this is the representation of giving an electron. So as you can see, if sodium, which has a positively charged, transfer to chlorine, so it has a symbol now, a negative. Okay, always remember that if an atom give up an electron, it became a positive. And if an atom accept an electron, it become a negative. That is why the chlorine, the sign of chlorine become a negative. Because sodium give up or share an electron to chlorine. Okay? Next slide. Two particles oppositely charged become closer that before and are held together by electrostatic attraction. So that this is actually named as an electrostatic attraction. So, it is forming an ionic bond or electrovalent bond. So, this is a best example for electrostatic attraction or ionic bond or electrovalent bond. Okay, next slide. When two atoms in molecule are held together by sharing of electrons, the chemical between is known as a covalent bond. If the element is shared lang, mag-share lang siya ng electron, it is the both electron will share, the both element will share an electron to each other. That is called as covalent bond. Okay? Let's go to another example. So this is the best way to define or to discuss a covalent. When a two element now share an electron, so this is actually the representation of it. Yan. Tingnan nyo, nag-share sila. A single element to another single element, then fuse and what else? Shared to each other. So that is the representation. So, when the atom shared one pair of electrons, as in, let's say, hydrogen 2, the force is so called single bond. If atom shared one pair of electrons, it is called a single bond. When the atom shared two pairs of electrons, it's called a double bond. And when atom shared a 3 pair of electrons or 3 to more electrons, we have triple bond. It called it a triple bond. So always remember, if an atom shared a 1 pair, it's called single bond. If an atom shared a 2 pair, it's called double bond. If an atom shared a 3 pair, it's called triple bond. Okay, next slide. While a certain amount of energy is given off during a bond formation, it requires the same amount of energy to break the bond apart. This energy which is necessary to break a bond is called bond energy. So, this is actually a summarization on giving and sharing and accepting and gaining. So, in sharing an electron, hindi basta-basta lang ito siya ma-form, hindi basta-basta ito siya ma-break. Sorry. If you share an electron to another atom, you can share it easily, but you cannot break it easily. You can break it in the name of bond energy. So always remember that one. Next slide. Metallic bond. Metallic bond is the sharing of many detached electrons between positive ions where the electrons act as a glue, giving the substance as a definite structure. It is only found in the metals. Of course, it is metallic bond. It is responsible for several characteristic properties of metals such as their shiny or luster, their malleability, and their conductivities for heat and electricity. Okay, next slide. So this is actually the summarization of both summative comparison of both metallic bond, ionic bond, and covalent bond. Always remember that metallic bond is in the middle itself, and metallic bond is always occur in the elements that is in the metal. Okay? Always occur lang yan siya in the elements that is in the metal. Okay. Let's go now on the comparison, on the summative comparison of both metalloids, on both metallic bond, ionic bond, and covalent bond. In metallic bond, always remember that in sharing and giving of electrons, we have metals plus metals. Metallic bond will occur in an element if an element is a metal. Comparing it into ionic bond, we have metal plus non-metal. Compare it to covalent, we have non-metal plus non-metal. Always remember that one. That in ionic bond, we can share and give, and gain, accept an electron in a different element. If in an element is metal, it's okay. If in an element is non-metal, it's okay. But in metallic bond, if metallic bond can be used in the metal plus metal, or if an element is in a metal, or if an element is includes in a metal. Comparing it in covalent bond, if it will be done if an element will share it to non-metal. Non-metal to non-metal ito siya. Okay? Always remember, metallic bond is metal to metal, ionic bond is metal to non-metal, and covalent bond is non-metal to non-metal. Okay. So, metallic bond, atom 6 stability, the same with ionic and covalent bond. So, metallic bond, atom release their electrons to become cations. So ionic bond, atom give off and accept electrons. Of course, it's either give or accept. Covalent bond, atoms share electrons with other atoms. So always remember that metallic bond will release an electron to become a cation, and ionic bond always give or gain or accept an electron, and covalent bond always share an atom. So, in ionic bond, it happens between atoms of a great difference in electronegativity, and in covalent bond, it happens between atoms of little difference in electronegativity. So, in metallic bond, there is no such electronegativity because in metallic bond, it always release an electronegativity, not accepting an electronegativity. Okay? Metallic bond also can bend without breaking. In ionic bond, easily break, but in covalent bond, fragility depends on the state. Ito na yung sinasabi ko na you can share easily but you cannot break easily. You can break it easily by the code of bond energy. So, metallic bond can conduct electricity and heat. Ionic bond, ability to conduct may depend on state also. And covalent bond, ability to conduct may depend on the atoms itself. Okay, metallic bond has a high melting and boiling point. Ionic bond, high melting and boiling point. And in covalent bond, we have low melting and boiling point. So that is the summative comparison of both metallic, ionic, and covalent bond. I hope you understand the differences between the types of chemical bond. So now let's have a check of understanding again. So I will be giving it in your GC to be answered. Then you will be you will be sending it to me by PM. Okay, so I will be giving this last understanding of yours. So this is actually an assessment on defining if you understand my whole discussion. Okay, thank you very much. So this is the last discussion that we have in general chemistry. So I hope you understand the small time that we've given. I hope that you've understand the whole topic or the whole lesson of general chemistry. So we will be having your examination next Sunday, which is actually November 29, if I'm not mistaken. So if you have questions, clarifications regarding to the discussion, you can raise that in our GC or you can PM me. So thank you very much everyone and have a nice day.